These are points M and N on an unnumbered Cartesian grid. We don't really need to worry about the numbers today because we don't really care exactly where M and N are located, just that they exist. M and N are called points in mathematical jargon. A point is zero-dimensional mathematically, meaning it doesn't have a measurable height, width, or depth. It just is a place. Now, in order for you to see things properly on your screen, I had to draw a big chunky dot that definitely has measurements. But technically, mathematically, a point is just a location without any true measurement. Hence, it's zero-dimensional. Today, we want to discuss one-dimensional mathematical objects, such as this. Now, you might be saying, Mr. Hale, yes, it has length. It goes from here to here, but it also has width going across, and that's true. In order for me to draw it, it has to have both height and width. But mathematically, technically, all we're worried about is how long this thing is. This goes on forever in both directions. Arrowhead and arrowhead on the end mean keeps going into infinity. This infinitely long path happens to pass through point M and point N. You'll notice I keep using the word path to describe this thing, even though I'll bet when you first saw it appear on your screen, a different word came to mind, and that word would be line. The reason I haven't been using the word line is because that word, line, has a very specific mathematical definition. In our day-to-day speech, we use the word line to mean a whole number of things that are actually quite different. That's not how it works in mathematical vocabulary. You can't have the same word mean a bunch of different things. A word has one definition, ideally. And in this case, a line, the word line, has a very specific definition. A line is a path that goes on forever in both directions. We just randomly choose 2 points on that infinite path to give it a name. A line is infinite in both directions. We would name this line by using 2 points that we know exist on it and drawing a line on top of those 2 points, like this. This means that the infinite line, indicated by these arrowheads on either end of this path on top, the infinite line passes through point M and point N. We chose those 2 points arbitrarily. They are no more important or less important than any of the other infinite points that this line goes through. We could draw another point on the line, call it J. That means we could change the name of the line without really changing anything else about where it travels. We could call this JN, 2 points that exist on the line with the line drawn above it. Or we could call it MJ, or NM, or MJ, or NJ. The order of the 2 letters doesn't matter. All that matters is that we have 2 points that exist on the infinite line, and we draw a shorthand for an infinite line over the top of those 2 letters. What if, instead of going on infinitely in both directions, your path starts at 1 point and goes on infinitely in 1 direction? On this drawing, our path seems to start at N. It doesn't go off into this space over here. And then it goes in this direction infinitely. You know it's infinite because of the arrowhead. While doing so, it happens to pass through point M. This path has a special name as well. It's a one-directional path. We call that a ray. It goes on forever through one point, and depending on how you look at it, either stops or starts at the other point. Unlike our line, which we saw on the last slide, if we want to name this ray, the order matters. We are going to put down the letters indicating the 2 points we have chosen, and then we are going to draw a ray on top of those 2 letters. But when we do that, notice there's only one arrowhead, and that arrowhead points in the direction of the letter that it passes through while moving on infinitely. The side that has no arrowhead is on top of the letter where the ray started. You could flip these letters around, but you then would have to change the direction of the ray in your notation. You could call this NM, but notice above the N there is no arrowhead. That's because it doesn't go through N infinitely. N is its stop or start point. There is an arrowhead over M because after passing through M, it goes on infinitely in this direction. A ray is infinite in one direction. A line is infinite in both. What if we go this way? This time we have it starting at M, passing through N, and going on forever in this direction. This is still a ray, but we've swapped the direction. What would our notation look like in this case? Remember that with a ray, the order of the letters and the direction of the ray drawn on top of those letters matters. In this case, we could write MN, but then the M would have to have no arrowhead above it because the ray doesn't go through M. It starts there. There is an arrowhead above N because the ray passes through N and goes on infinitely. We could flip the letters around, but notice that if we do that, the ray on top also flips. The M has no arrowhead. The N has the infinite arrowhead. What if you don't pass through either point? You just go between them, like this. How do you think we would notate that? What do you think we might call this kind of path? This is known as a segment. And a segment connects 2 points, but doesn't go through or beyond them. It just makes a path in between. You may notice a pattern as to how we do the notation. We pick the 2 letters and then draw an example of our line, ray, or segment above those 2 letters. This is no different. We would notate this using MN and then drawing a segment, that is a path with no arrowheads, above the 2 letters. In this case, the order doesn't matter. We could flip those around and have NM with the no arrowhead path, the segment, on top. To wrap up, a line is a path that goes on forever in either direction, and we just choose 2 points on that infinite path. A ray starts at one point and then goes on forever in one direction, passing through a second point. And a segment connects 2 points, but doesn't go beyond them. If you have any questions, please email me or jump into my office hours between 1:45 and 3. There will be a short assignment on your OneNote, and I will see you tomorrow morning.